We are using tables. And if you can look at any one of your own tables, you would notice that tables are given at the end of the textbook usually based on some information. For example, when you look at the years, you will notice that not all the years are there. In this case, in the examples that we have years from 1 through 35, and then from 35 to 40, we don't have any year identified. Then it goes from 40 to 45 to 50 to 55 and so on. On the other hand, there is no specific interest rate table for the numbers that are between these numbers. So you have a table for, let's say, 8%, you have one for 9%, but you don't have anything for 8.3%. In those cases, you can either use the formula directly, which is the more appropriate way of doing it, but if you are told to use the tables, then you don't have any other way but to interpolate between the numbers. Now, interpolation is a linear interpolation, which says if this number is such, that number is such, when you connect them together with a linear line, and you're looking for a number in here, you just go up and read it off that line. Now, if you look at the factor formulas, they are all nonlinear. Okay, they're all nonlinear. They may look like this, or they may look like that, but they are not linear. So you always get a difference when you do the interpolation. If you use the original formula, you get the actual value. But if you use interpolation, you get a little difference between the number that you find and the real number. However, the differences are not really that much, and if there is no access to the formula or no way that you can calculate them through the formulas, these are usually the better way of doing the calculation. So let's see how we interpolate. Let's take the same example, which is right here, and this one is for 15%, and we are looking at the year 35 to 40. Okay, we're looking at the year 35 to 40. Interpolation is very easy. Don't get confused with interpolation at all. It's a very, very easy process. So in this case, let's say that we want to find one of these factors. Let's pick up the first one as a P given F. P given F, 15%, and 37 years. We want to calculate this number. We go to the table, and lo and behold, we don't have a 37-year written in there with the number. So what do? You look at the one below that and one above that. In this case, this one has the number for 35, and has the number for 40. We do have those two numbers. Can you tell me what those numbers are? For 40 is?
It's 0.0037.
0.0037, and for 35 is?
0.0075.
0.0075. So this number, whatever that number is, it's between these two numbers. Okay? So what you do is you look at these two numbers. You look at these two numbers and see what is the difference between those two numbers. So it's 40 minus 35 is 5 years. Then you subtract these two numbers from each other. Okay. So I'm going to do 0075 minus 0037, which would give me 40 and 0.0038. Is that correct? That is the difference. So for 5 years, there's going to be this much difference. How much is for 1 year? Then you divide that number by this difference, by 5, and you get a number. That number probably be 76. It would be 00076. So you get such a number. This difference is for 1 year. The difference between these two was 5 years. The difference between these two was this much. So you divide it by that difference that you have in the years, and you get a number. That means starting from 35 to get to the 40 linearly, every time this much is changed. Okay? How is that changed? Is it increased or decreased? In this case, it is decreasing. So for 1 year is this much. How much is for this difference? 37 minus 35 is 2. 2 times 0.00076 will give you, so it's going to change this much. From what? From this value. So it's going to be 0.075 minus 0.0152. We are only using 4 decimals, so you can drop that. And that would give you a 0.060. This is this number using interpolation. Now you can memorize formulas, but this is much easier. Subtract the years, subtract the values, divide them by the difference between the years, and then multiply how much this is. Now notice what I did. I said from here to here is 2 years. What about this? I can actually do it from that end. I can say from 40 to 37, there's 3-year difference. So I can multiply this 1 year number by 3, and then what do I do to this? I will add that to the same number. Let's do another one and see whether you can do it. Calculate P given G 15% in 53 years using interpolation. What is that number? So you go to the table. What do you look?
What's before and after?
50 and 65.
Okay. And what are those years?
50 and 55.
50 and 55 that we have in the table. These two numbers are in the table. What are these two numbers? Anybody
44.09.
44.09.
58. 6. 6.
Okay. You got that by using calculator? Table. Table. The number in the table.
58.
58. And this one is 0.2558. Okay. So you look at these two numbers and see how much difference is between those two numbers. 55 minus 50 is 5 years. And you look at these two numbers, and you say 44.2558 minus 44.0958 is going to be 0.16. Okay. Now this is what you are telling yourself now. For 5 years, there is going to be this much difference between these two factors. So what is the difference for 1 year? You divide them by 5. So you say 0.16 divided by 5, which will probably give you 0.032. So that is the number for 1 year, the difference for the number for 1 year. Now you have two choices. You can either go this way or go that way. What are we looking for? We are looking for PG, 15%, and what is that? 53? Okay. You can go this way or that way. Which one would you like to do? Down. Okay. So I'm going from 50 to 53. What is the difference? 53 minus 50 is 3. For 1 year is this much. So how much is for 3 years? So it's 3.032, which would give you probably 0.096. That's for 3 years. So what do I need to do from here to here? Is it increasing or decreasing? It is increasing. So I need to add to this number. So it's going to be 44.0958 plus that number, 0.096. And that number, which is going to be 44.1918, is the interpolated value for this number. In reality, that may not be exactly the right number. If you put them in the formula, formula will give you the exact number. Now, what if you wanted to go this way? What would you do? You first find the difference, which is 2 years. Multiply 2 by, instead of 3, multiply 2 by this number, okay, which you get is 0.0064. And then what do you do with that number? You will be working with this number. What would you do with that number? You will be subtracting from this number. Why subtract? Because when you go this way, it is reduced. Okay? So for 2 year difference, you will be subtracting. This is a very simple process. Don't get confused, but practice. Sit down and Do this for yourself for a few of these years and then see how you do. When you get comfortable, you can easily do it. Again, these are for the cases that you're dealing only with the table. And sometimes your quiz says, use tables. Which means if you use formulas, it's not acceptable. You need to be using tables. If you only have tables, then your access is restricted, because there are some years not in here. The other case is, what if you go between the interest rates? You look at your book, there's, I don't know, 8%, 9%, 10%, 11%, and then it gets to, I don't know, 18%, and after that is 25%. The tables are like that. Or when you look at the early tables, it says for 0.5%, for 0.75%, for 1%, for 1.25%. There are all tables in there. But then when it gets to 8 and 9, there's no 8.5 or 8 3/4 or something like that. So those numbers are not there. Based on the three tables that we are going to be working with, we are going to do an interpolation assuming that we don't have access to 12%. 8% and 15%. If you're given 8% and 15%, how would you find the value of a factor, any factor, using interpolation for a specific interest rate? Let's say that I am looking for f given p, 12% and 10 years. And the only thing that I have is tables for 8% and 15% at hand. Remember, in this case, the year is identified. But I have only 8% and 15% tables. How would I get the value for 12%? The same way that we did with the previous one for the years, you do this thing for the interest rate this time. Okay. So you look at this one for 8%, this one for 15%, and then using interpolation we will find a value for 12%. How do we do that? We are going to be looking at these two numbers. You now say that the difference of 15% and 8% is 7%. You will find these values that a couple of nice people are going to tell me what those numbers are.
The 8% is 2.1589.
2.1589. And for 15% is 4.0456. So you subtract those two numbers from each other, 4.0456 minus 2.1589 is going to be
1.8867.
1.8867. For 7% difference, I have this much difference in the factor. So how much do I have for 1%? And that's where you would divide that number, 1.8867 divided by 7. And it would be 0.2695. So you're saying that for 1% there will be this much difference. So let's look in here. I'm going increasing. So this is going to go increasing. So to get this number, I have to 12% minus 8, which is going to be 4. 4% difference. For 4% difference, I have to do what? To multiply that number by 4, 0.2695, which would give me 1.078. And then what do I do with this number? Add it to this number. So it is 2.1589 plus 1.0780, which is going to give me 3.2369. Okay, this is an interpolated value. Now, look at the real value in the 12% table. The real value from 12% table is 3.1058. Okay. Interpolated value using 8% and 15% tables is 3.2369, which is close enough, but not exactly the same, the right number. Now, the less the difference between these tables, the more accurate the number gets. In here, I have interpolated between 8% and 15%. Had I interpolated between 11% and 13%, I would have gotten a very close number to this number. So the difference makes that. What if I wanted to actually find, instead of 12%, what if I wanted to find the value for 12.7%?
You should do 12.5.
Process is exactly the same. This step is going to be the same. You're trying to answer, or you're trying to pull the hair? 8% and 15%, exactly the same thing, because those are which are available. Okay. So you do this. You subtract these two values from each other. You divide them by 7. You get the change for 1%. The only difference shows up here. Instead of 12 you would have 12.7%, which will make this 3.3, or no, more, sorry, 4.7. 4.7 will make this 4.7. And then what do you do in here? Instead of that 4, you will have 4.7 multiplied by that number, and so on. So the process is really, really simple. What does finding a rate of return means? The process of finding rate of return. Most of the time, when we have different cash flows, and I write a very simple one because we want to do the work all together. Let's say that I have in the case of rate of return, we want to see what is the equivalent of this project at one specific point of time, which is preferably the present value. Okay, that's present value analysis. What is the present value of this project? And what is the rate of return, and what is the rate that makes the present value 0? Which means all payments and all income will be the same when they are calculated at the present time. So that is what we do. So what is that we don't have? We have the years, we have the numbers. What is that we don't have? It's the rate of return that we don't have. So the idea is, if given a cash flow, in which everything is given to you except the rate of return, then what are your options to do? How are you going to calculate that rate that makes the present worth of all positive and all negative equal, such that when you add them up, the result is going to be 0? So this is what we are going to be doing. First, the positive ones. How am I going to write the present worth, let's say PW PW1? Okay, the present worth for the positive ones, incomes, revenues. You're writing the formulas initially. You're not dealing with the interest. You're just writing the formulas first, and then we will work with that. So how would we write the formula? First is this one. It comes down here. So it would be 4,000 times what? It's P given F, I, and 10. Okay? No formula. No formula. So this is brought here. Plus what? 2,000 times P given A, I, and 6. This is 0, 1, 2, 3, 4, 5, 6. The period is 6. Okay? This is not still in present worth. Where is it located? It comes down here. Okay? Comes down here, and from here it goes to here. So this needs to be multiplied by P given F, I, and 1. Okay? Why is this 6? Because the standard form is like this. This is the standard form. Always look at the standard form. 0, 1, n. That's the standard form. Put that standard form over here. So where would the 0 be? 0 will be here. So what would this be? 1, 2, 3, 4, 5, 6. That's where the 6 comes from. Okay. And when you convert this into a number here, you still need to move it 1 year back. So this is going to calculate the positive cash flow. Now I cannot calculate this because I don't know what I is. So I don't know which table I should go to. So let's look at the other one. PW2, which is going to be the total of the negatives, which is going to be, this is already at time 0. So that's going to be minus 5,000 minus 3,000 times P given F, I, and 8 years. One additional piece of information I have, because I'm trying to find the rate of return. Rate of return is when you get PW1 plus PW2 equals 0. So I am actually comparing these two values. That's what I'm doing in here. When they become equal, the values of them, not the signs. When they become equal, that rate of return is the 1. But I don't know what the rate of return is. So what do? I'm going to start guessing. Okay? You start guessing. Is it 1%? Is it 2%? Is it 5%? Is it 10%? I don't know. Start from something that makes sense. Assume that there is no rate of return. If there is no rate of return, then you can add these numbers. 5,000 plus 3,000 is 8,000. This is 4,000 plus 1, 2, 3, 4, 5, 6. 6 times 2 is 12,000. 12,000 plus 4,000 is 16,000. So up here I have 16,000. Down here I have 8,000. From 16,000 to 8,000 there is a significant difference. They are not close to each other. So I have to make sure that these numbers at the top are going to be reduced. What is going to reduce them? Interest rate. When I bring them back to here. The higher the interest rate, the more reduction you will get. Okay? 4,000 here, when the interest rate is 1%, is a value here. If it is 15%, it's a significantly lower value in here. Because when you look at the P given F, that's how those numbers will look at. The more the interest rate is increasing, the more they become smaller and smaller. Okay. So we will start with something. Is 8% good? 12% good?
12%.
Okay. So let's get this part of the class. Find these values for 8%. This part of the class, find these values for 12%. Anybody who has the number, please let me know.
Got it for 12%.
You got the number for 12%. What is PW1? 8,630 something, 0.13. You got the other one too?
8%.
No, for 12%.
Oh, yeah, negative 6,211.
6,211.7. Okay. It's 10,413. 0.48.
Collected, there you go.
For PW2,
Negative 6,000.
negative 6,000.
620.
620. 620.90.
90.
Okay.
Because I heard the snacks.
Looking at these two, do you think we should reduce the interest rate or we should increase the interest rate? So we will check this for 15%, we'll check that for 20%. If you see from, this is something that you can look. What is the difference in here? It's about 3,500 or so. Okay. What is the difference in here? It's about 2,400.
24, yeah.
Okay. 8,662. Okay. From the difference of 3,500, I went to the difference of 2,400. Do you think I should test 13%, 14%? No. Oh, I'll test 20%, 25%. Okay. You will be testing something that it's just like the interpolation. This is the difference in here. For 4% change, I got that difference. So if I go to 15%, it's not going to help me. If I go to 16%, it's not going to help me. Maybe 20%, maybe 25%. And that's what I will be looking at. Now, you get to the point, this is the, in your adventure, you get to the point which, I don't know, I'm just putting the numbers in here, these are not the right numbers. You get to 18%, and this total is positive right now, this total is positive. At 18%, this total is positive. At 20%, you check, and this total is negative, which means there is a change of the sign. At that point, you say, the interest rate is between these two. How do you find an interest rate which is between these two? Interpolate. We just learned that. Interpolate.